So, good morning, good afternoon, and good night. So, we're going to talk about the overview of the techniques, which is that technique is called Newton's-Rhapson method. So, you may ask, ano nga ba yung Newton-Rhapson method? Ang Newton-Rhapson method is an interactive root finding algorithm used to approximate solutions of real-valued functions given a function of f of x and its derivative f of prime x. The method starts with an initial guess, which is x is 0, and interactively refines the approximation using the formula. So, this method, the method converge quadratically if the initial guess is sufficient sufficient close to the root, and f of x prime is not equal to 0 at the root if it is widely used for solving nonlinear equations due to its inefficient and simplicity. So we will tackle more about the Newton-Rhapson method in this video.
Okay, hi everyone. Before I start, I will first introduce myself. I am James Rimando from BSME 2A. So for our project, Newton-Rhapson method, we choose C programming language. C was selected for its efficiency in numerical computation and its suitability for implementing iterative algorithms like Newton-Rhapson. So the code was developed and compiled using Dev C++, a readily available IDE, which stands for Integrated Development Environment. The combination of efficiency, control, and accessibility made C the optimal choice for our project.
To my part, scope and delimitation, the program focusing on solving nonlinear equation using the Newton-Rhapson method with the following constraint. First, solves equation of the form f of x is equal to 0 and f of x is equal to 0. Predefined as x cubed minus 2x minus 5x cubed minus 2x minus 5. Accepts user inputs, initial guess, tolerance, for example 0.10010.001, and the maximum iterations. Third, outputs iteration with x raised to 0 and x raised to 0, f of x raised to 0 and f of x raised to 0, f prime of x raised to 0 and f prime of x raised to 0, and x raised to 1 and x raised to 1. Stop when absolute x raised to 1 minus x raised to 0 less than tolerance x raised to 1 minus x raised to 0. Tolerance or exceeds max iteration. Limitation requires manual modification of f of x and f of x and f prime of x and f prime of x in the source of code.
Sample problem. Solve the equation x cubed minus 2x minus 5 is equals to 0. So this equation represents a scenario where engineers need to find a critical point of a cubic function modeling material stress. The root corresponds to the stress threshold where the deformation occurs.
So good evening everyone. So let's now discuss the procedures on using the program. For the Newton-Rhapson method, first step is to open a CIDE program. Example is the Dev C++ code blocks or any text editor with GCC. So for our group, we use the Dev C++ program. So let's open Dev C++. Okay. Okay, here. So the next step is to create a new source file. So go to the file, new, and then source file. So file, new, okay, file, new, source file. Okay, so here is the blank sheet for the code. This is where we put the code. What's the next step? The next step is to the third step. After that, we enter the C code for the new Rhapson. Here's the code. Copy, and then go to dev C++, paste. Okay, as you can see, here is the code. Easy. Okay, next is check if there's some error. So let's check the code if there's some error. Okay, debug. Let's see. Okay. Okay. So there's no error in this code. So after checking if there's no error, the next step is to compile the okay, execute, compile. Okay, save file name to save. Okay, no errors, so we can see here below, no errors, no warning, and this is the file name, program for Newton-Rhapson method 2. Okay, after that, press the run command. So here in execute, you press run or F10. So there's a pop-up after we press the run. So this is where we test the iterations. Okay. So what's the next step? Number 7. After saving it, a pop-up will appear like this. So this is the pop-up. The pop-up says enter initial guess. So let's try pressing 1. Now try pressing 1. Okay. Next step is enter tolerance. So we put 0.0001. Okay. Enter. Enter max iterations. We choose 10. Okay. So fast. It was fast. Okay. Now after that, after executing the commands, you will now found in the pop-up the roots for the problem. So these are the roots. So as we can see, it takes 8 iterations to come up with the roots. So our iterations is, say, it's more than enough than the iterations we need for this problem. So the root is 2.094551. So that's the roots. And it takes 8 iterations to arrive to this answer. So now we press any key to continue. Exit. Escape. So the conclusion. The root for the equation x cubed minus 2x minus 5 is equals to 0x cubed minus 2x minus 5 equals to 0 is approximately 2.094551. This solution helps engineer identify the stress threshold 2.094551 Pascal, ensuring structural safety. So that's all. Thank you.